Let's begin. 5.5 is on solving exponential equations. You're going to learn how to solve equations that have variables in the exponents. So the first thing that I have us writing down is this. If the bases match, then the exponents are going to be equal to each other. Let me show you what I mean. If I have a problem where I have 5 to the x power is equal to 5 to the second power, if I have something with this base of 5 to the x power and this base of 5 to the second power, if these two bases match, then the exponents have to also be the same. 5 to the second power is equal to 5 to what power? Well, it's 5 to the second power. X has to be equal to 2. So this is how we're going to set up most of our problems on the 5.5 worksheet. We're going to be trying to get these two bases to match each other. This is the basis of everything that we do. Okay? So here's how the problems start. Let's do an example like number 2. And the problems are not just as straightforward as they were before. 5 to the x minus 1 power is equal to 25. There's a few of you who can do this in your head. There's a few of you. As a matter of fact, I'm curious. Let me do a quick survey. How many of you could do that in your head and you know what x is already? Raise your hand. Okay, I'm guessing about 50% or less. Doesn't look like everybody. It looks like less than half can do it in your head. So I need to show a way that everybody can do. So here's what I'm going to do. Since I have a variable in the exponent, I'm going to try to get this 25 into base 5. I can rewrite the 25 as a power of 5. 5 to the what power is 25? Let me think about that. 5 to the second power is 25. And that's the same thing as 5 to the x minus 1. If the bases match, then the exponents have to be equal to each other. So what I can do, if I have 5 to the x minus 1 equals 5 to the second power, I can actually move this over here, and I can say x minus 1 has to be the same as 2, and I can figure out what x has to be. Do you know what x has to be? If you wrote down 3, 3 is the correct answer for number 2 that we're going to do on worksheet 5.5. Keep in mind, if I don't know what I'm supposed to do with the 25, you're not dividing. What you're doing is you're saying, how can I turn a 25 into a power of 5? It's either 5 to the first, 5 to the second, 5 to the third. That's how you're going to do a lot of these problems. Okay, next level. This is number 4. Number 4 says 2 to the 3x power, 2 to the 3x is equal to 1 over 64. What I want you to do every single time is start thinking about, well, this is 64, I don't divide. What you're going to want to try to do is you're going to want to try to get the 64 into base 2. And so you will literally need to figure out, is it 2 to the 4th power? Nope. Is it 2 to the 5th power? Is it 2 to the 6th power? Okay. So how can I write 64 into base 2? The first thing I can do is figure out it's 2 to the 6th power. So then this is what I write. 2 to the 3x is equal to 1 over 2 to the 6th power. Remember, that 64 is in the denominator. The 2 to the 6th needs to be in the denominator. So I wrote a little note on the side. I wrote this: find 64 in base 2. I was trying to think of what 2 to the what power was equal to 64. Base 2. 2 was my base. The next thing I need to do, since I have the 2 on bottom, this is in the numerator on the left. On the right, this is in the denominator. I don't want this in the denominator. I need to move it up. That's where there are arrows there. I want to remind you something that we talked about in section 1. Negative exponents move from the top to the bottom or from the bottom to the top. We wrote that down before, but let's write it down again because we can use that here. 2 to the 6th in the denominator is the opposite in the numerator. Well, what does that mean? If it's 2 to a positive 6 in the denominator, then in the numerator it's 2 to the negative 6th power. So this is my next step. Move this up, change it to a negative exponent. I'm going to have to zoom out just a little bit for you. What I used was, I used a negative exponent. Now I have 2 to the 3x is equal to 2 to the negative 6. And so, that means 3x has to equal negative 6, and I can figure out what x is now. X is equal to negative 2. If I want to, what I can do is I can actually put in 2 to the 3 times, what did I get? Negative 2, and see, does that work? I can actually take that and plug it into my calculator to see, do I get the right answer? If it works out, that says 3 times negative 2, I get 1 over 64, which is what the correct answer should be. Okay, we have time for one more example. This will be our last example, and then we'll be done with our notes for today. It's number 16. Let me raise that up for the person in the back of the class who they can see it. Seven to the 3x is equal to 1 over 343. I want to get this 343 into base what? What base do I want this in? You should know that. I want to get this into base what? Base 7. So you may not know what 7 to the whatever power is 343, so I recommend take your calculator. 7 to the what power? Do you know 7 to the first? You already know that one, don't you? 7 to the second? Do I need to tell you what that is? What is 7 to the third power? If you're not sure, use the calculator. It knows them all. So that is 7 to the third power. And it's 1 over 7 to the third power. We can move that up. And then we can figure out that these two exponents need to be the same. And that x should equal negative 1. We'll end our notes right there for part 1.